CUA has developed small, low-risk, cost-effective propulsion technologies that are triple purpose. First, the thrusters can extend your mission by orbit raising to a higher altitude. Second, the thrusters enable orbital collision avoidance. And finally, the thrusters can be used at end of life after the mission has been completed to re-enter Earth's atmosphere, thus decreasing potential orbital debris.
So the PUC system, the propulsion unit for CubeSats, uses a microplasma discharge and a refrigerant to superheat that refrigerant and create thrust. The CHIP system, CubeSat High Impulse Propulsion System, uses a micro-resistojet, and that superheats the refrigerant and it comes out as thrust. Main thrust would propel it this way, and then attitude control can rotate, and you can even do true roll maneuvers. The monofilament vaporization propulsion system utilizes a combination of 3D printer technology to feed and melt a plastic fiber and then vaporize it to give you thrust. The FPPT system, a fiber-fed pulsed plasma thruster, FPPT, uses a high voltage discharge to create a plasma that then vaporizes a little bit of Teflon. It also is ionizing that Teflon and using electromagnetic acceleration to get very high velocity out of the ions. There are a number of monopropellants out there that are effective, but they tend to burn really hot. So we started exploring some monoprops that would have a much lower flame temperature, and we came up with CMPX, which does in fact have a flame temperature that's hundreds of degrees Celsius lower and still retains much of the performance of some of these other monoprops. So that's what led us to the MPUC system. A little more specific vision is with the micropropulsion systems that we do. We believe our technologies can enhance those systems for both maneuverability and then deorbiting, so that ultimately you can help alleviate the ongoing orbital debris problem that is starting to escalate.